So good morning, everyone. My name is Manuel. I'm going to introduce to my work is development of ground profile models from terrestrial laser scanning, TLS, and drone lidar, ALS, in Pinus alepensis stands. How can we pass here? This is the puntero, and to pass with this, okay. So I belong to a bigger project, that is TLM project, is developing a replicable methodology based on users' needs and preference to the generation of tree-list map to project forest management and scenarios under climate change conditions. So this is a project. I am this lucky guy that we have this fellowship. So then this project have a 3 years horizon, and the first task is this one, Pinus alepensis crowd profile model. So what is a crowd profile model? There are some equations that describe vertical and horizontal structure of the crowns representing their shape and the size. So the common variables that we have is like total height, CVH like crown base height, maximum crown radius here, and the height at these situations occur. And with these little variables, we can calculate the other ones. So why is it important to have a crown profile model? So because this is really important to forest fuel characterization, the crown and the height and the density determine the fire risks and the forest dynamic understanding. There is a good tool for adaptive management in climate change. Now we have also just profile models for Pinus sylvestris, Pinus radiata, Pinus pinaster, and for Pinus alepensis there is no crown profile model. So for many simulation tools like Siman4 or Medfaint, for calculating the crown profile model for Pinus alepensis, we have many assumptions that we lose sensitivity for these tools. Make some assumption for make the crown is a cylinder or a cone or something like that, and we underrate the prediction of these powerful tools. Okay, I'm playing with the things. So the first objective is to develop a novel methodology to capture tree crown data for the advancement of the crown profile models. Because in the past, for a made a crown profile model is really difficult, costly, and not too much precise. And the second objective is obviously develop the crown profile model. So the study area, we have 56 circular plots of 70-meter radius in central Spain. We distributed this in like 10 or 12 plots in 5 zones, really near to Soria, where we live. One place is Astudillo, Palencia, Fitero, in Navarra, Ardisa, really near to Huesca, also Zaragoza, and Torrijos, also Zaragoza, and in Cifuentes, Guadalajara. The field data we collect in every plot, like classical variables from a traditional forest inventory, like total height, the height of the live crown, diameter at bridge height, and these variables. With the TLS, this scanner, we put like 5 or 9 scan positions. This is the scan, and we put it in the center at 12, 3, 6, and 9, no? If we see a clock. If we have too many trees or many density in the plot, we put more scans to avoid the shadows that make it the trees, no? And use this little thing, these spheres, to connect and register the scan for every scan. And the other thing, these little chess things, there are ground control points, because the new thing is to mix with the terrestrial laser scanner, with the little photo, with the drone lidar. So with these things, we can co-register the terrestrial scanner and the LiDAR, the drone data. We also made flights with, to connect 3 plots in the same flight. And also we used a multispectral sensor. So with this data, our results that are high resolution 3D point from cloud generate. This is a plot with only terrestrial laser scanner. And we have here in this plot 54 million points. So typically in PENOA flight, if you know the project LiDAR PENOA flight from Spain, we have like 1 or 2 points from a meter square. So in this I have, I don't know how many points, a lot. So it's really density. This is a tree. So with the terrestrial laser scanning, we can like the digital twin of the tree. So it's not very fair, this photo, but in my computer I see really beautiful, really better. As we have a really precisely, or the little leaves, really precisely. So with this product, we have to co-register the scanner, terrestrial laser scanner with the drone data. We have to put it in a correct coordinates. Then we have to isolate every tree in the plot, like it's really hard work. And with this digital twin, we can make a slice at like a half meter in the height. And with this shape here, we can have all the variables from the final ground profile model. So we have only just preliminary results. We have 56 plots, and we just only co-register 22 plots at this time. And we have 53 trees isolated. Just it's a very poor number, but it's a preliminary result. So, but with only 53 trees, we have this variable, and we have different variables at a tree level and a plot level, and also with these variables, they are going the variables that we have. We also have a true ground data, and there are these variables that we wanted to predict. With this data, I made a just preliminary result, principal component analysis, so it's important to DBH and basal area. And we have just three models tested. That's with only 53 trees. I have from crown volume a good adjust. Very bad for crown height, but when we have more data, I think we are improve these results. So conclusions. First conclusions, TLS and LS integration provides a detailed canopy inside, so it's a good news. And the second conclusion is promising preliminary models for Pinus alepensis. So in the future research, we have to model refinement, extension this methodology for other species and forest types, and to integration with other tools like MED4 or CMAN4. So thank you very much for everyone.